So, welcome everyone. I hope you still can hear me well. I'm Piotr Korlaga, a software engineer in Technip FMC, and I'm going to talk today about OWASP Top 10, what to be scared about, or rather, what to be aware about. We'll talk about security. I will give you some examples of attacks and some advices how to be prepared, how to prevent those attacks. And I will appreciate some interactions with you guys. So if you have any question, any comments, whatever, you can always write it in chat. I will be looking at it from time to time. So starting from the beginning, what is OWASP Top 2? So OWASP Top 2 is basically a standard or like a ranking of topics that we should be aware if we are creating web applications. And here is the list of those topics. So it's like a ranking, right? So we should consider the first one, broken access control, as the most important one, and the A10, server-side request forgery, as least important. Not really, because it's still top 10 topics and top 10 vulnerabilities in web applications. So in this presentation, we will actually cover all of them. And how do OWASP decide what is the most important thing, what is the least important thing? So they have their own ways. As you see, they have like rating methodology, and they take to the account technical impacts, they take explosibility, weakness, prevalence, and so on. However, I'm not going to focus on methodology today. I'm going to focus on changes, because what happened in 2021? They basically released another version of OWASP Top 10. And there were many changes. You see many arrows here, right? So there were some parts that really changed. And let's discover today what actually changed in OWASP Top 10. What actually changed? And if you ask me, so there were so many arrows, so many things changed, probably something was removed, right? But actually nothing was removed, but there were new things. So how did they achieve that? Getting new things to the standard without removing anything. So they basically merged something. They have like number 4 was position 4 was XML external entities. Now it is merged in security misconfiguration. And the same happened with cross-site scripting. It's now injection. And insecure serialization was also merged to another point. I will cover that in details a little bit later. And of course, they added new categories. Insecure design, number 4. Number 8, software data integrity failures. And now at that point, software and data integrity failures contain insecure deserialization. Right? Yes, right. And number 10, server-side request forgery. So let's start. I'm not going from the top to the bottom. I'm going from new to the old one, let's say. So first of all will be new point. Number 4 was insecure design. And what does it mean? This is something entirely new. So let's take a look at CWE. So what is CWE? If anybody of you wonder, is this? It's basically what does it mean, first of all? So it means common weakness enumeration. So it's another catalog, really big catalog, have thousands of weaknesses, but it contains basically every, or the most popular, I would even say every weakness that can exist in software, especially web applications. So if you see here, this is like standard Java code, try and catch So where is the problem? What is insecure design here? So from first point of view, everything looks good. But if we go into details and we check what exception can contain, so we can see it can contain like really sensitive informations, right? Like account numbers. This is probably very sensitive. But if it's SQL exception, it will contain everything what is in database. So if you reveal that information in your logs, it's probably not what you really want. You shouldn't reveal personal data in your logs, right? Second example is actually insecure design from the perspective of process. So this is very common process. Almost if you ever wrote an web application, for sure, you design something like reset my password process, right? And this is the reset my password in Instagram, if any of you have Instagram. And what can go wrong here? So actually, this process on Instagram looks like that. If I put the email here, like Joe Biden, White House Gov, I will get an email with the link to reset my password, or actually I'm getting an information that this user doesn't exist. If I put it my personal email, I get the information, so the email sent. So actually some information was revealed here, and I'm sure that was not intention of Instagram. They're a big company. It's owned by Facebook, as you probably know, but they still did this mistake. So basically they are revealing what is their customers. And from that screen, we know that Joe Biden doesn't use his email, his working email on Instagram. I know he has an account on Instagram, but he probably used different email. And you have to remember, like, the bad guys, they are not really looking only for passwords. They're looking for information, and they can put some pieces of information together. So the piece of information which you can get from Instagram reset my password flow is actually, for example, who from the White House has Instagram and use his work email to do that? Like, maybe it's not so, maybe that person is not so responsible. Maybe we can explore that person. So, like, the bad guys, they want to get the information, and they will use Instagram for sure. Believe me or not. So as I mentioned, this is one of example of insecure design, and we should also always design secure processes. So we shouldn't basically reveal that information. Just give user a message that email was sent. That doesn't matter. Don't inform anyone that user exists, right? And by the way, disclaimer, if you are interested in Instagram and travel, I have my own Instagram. It's Piotr Podróżuje. You are welcome there. But let's get to the track. Software and data integrity failures. This is also a new category. And what is more important, the old one from 2017 was merged here, right? So insecure deserialization is here now. So to give you some example what can go wrong, let's take a look at JavaScript code. If anybody can tell me what can go wrong here in the chat, maybe. Or if not, then I can tell you guys that what can go wrong. So in theory, this file is hosted, this jQuery file is hosted on some server, right? And we don't know who has access to this server. We can trust Google APIs, but maybe we shouldn't actually. Maybe we should use something like integrity tag. And this tag, if we use that with the source tag, it's actually our browser will check if someone changed that file. If that file was changed on that server, then we will get an error on browser. And yes, so there is a question in the chat. So the path should be hidden. Yeah, not exactly. So I would say like the solution for this is to really use the integrity tag. And in that case, as you see, you will get this this error in your browser, and your web page probably will be broken, but at least it will be secure, even if someone changed the content of this file, right? Another thing is actually serialization problem in Java. If you guys use Java and if you use serialization, you have two problems. I would say, not sure if you are aware, but serialization in Java is big issue from perspective of cybersec, and I will tell you why. So what is basically serialization? So we have some basically class value object with one value, whatever it is, and we want to put it into file. So how to do that? This is very easy. You just need to open file, open object output stream, and just write the content of the file. And the result will be just a bunch of bytes on your disk with some message, right? Hi message. But what is the problem here? This is not encrypted at all. So of course, I can change that message. Hello, right? I changed that on the disk and nobody knows I changed that. But what is even worse, I can change the class that was serialized. So instead value object class, now I have a gadget class and I can inject some comment. And if you take a look at that line, what will happen? Actually, if that serialized files containing that class will be written by your Java application, that command will be executed. So you can imagine you can get like environments variables, and environments variables can contain passwords or users or some sensitive data that you don't really want to reveal. So this is really big issue. And if you think this is like out of the blue, nobody had this problem in the app. So I would recommend you to go to this repository. It's on GitHub, Why So Serial. And there you will find a list of libraries that has exactly this problem. And let's take a look. What is this? This is Java number 7. So if you use Java number 7, update 21, you have really problem because you have this issue in your library. And take a look at this. Probably if you're a Java developer, use Spring Core. Again, version number 4 had that. This is not really updated list, so I still recommend you to go to that website and check the new facts. It's really interesting to experiment with these failures. But to give you an example how to prevent those attacks, this is the standard way of reading the file. So we are reading the file. That was our class. You remember value object. That doesn't matter. It's ser or whatever. It's just some file. So we are read that object. And in that case, we have problem because we haven't verified if that file was changed and the content of the class was changed. We somehow has to be secure. So I would recommend, if you really have to do serialization in Java, I would recommend you to use that class. I think it comes from Apache Common. I'm not sure, but you can Google that with this name. And with that class, you can actually check if the class was changed or not with this single line. And if you are checked, you should be secure. But anyway, if you really need to serialize something, I would recommend use JSON, use something else, but not really the default serialization mechanism in Java. All right, another new category, the last new one, server-side request forgery. So what it is? Let's imagine we have an API, right? And we are gathering information about cats, or basically cats or funny memes with cats, some pictures of cats. We can upload the picture, but also we can give the URL, and our application will download that picture for us. So that parameter, this is basically the request. We have post request. We do post request with link to funny cats, right? And we have those parameters. This parameter image URL. And what can go wrong? So if something else is accessible from that server, it can be probably accessed as well, and the content can be downloaded. So let's imagine the situation if we have admin panel, and some admin that, or some dev that created that admin panel, they thought, okay, it's on localhost only, so I don't need to do any authentication. Why? It's an admin, it's admin panel on localhost, nobody can access, only me, so it's fine. But what if our funny meme app can access that? Then all the content from localhost and admin panel will be revealed, because probably the response of that request is actually everything what is downloaded from this URL. So it's not downloading only images, not only pictures, but anything what we gave you. So the solution for that, someone told me, okay, so let's create allow list, let's create like blacklist and blacklist some localhost. So actually localhost won't be allowed in image URL. We'll do validation. We have to always remember about validation. But validation is tricky. So guys, let's imagine we create a blacklist and we validate this image URL. So localhost is now, we are not allowed to use localhost in this image URL. But what can go wrong? So you actually forget that localhost is also an API address. Okay, you will say, no problem, we will blacklist localhost and this number. But do you guys are aware that zeros in IP address are optional, and actually it will be resolved to localhost as well without zeros? And there is even more problems because this is binary numeral notation, and these funny numbers are also resolved to localhost. And what even worse, there is hexadecimal notation, and this is also localhost. So as you see, like blacklisting just localhost can be not so good idea. Probably the best solution, if you really have to give some URL in some parameter and you're going to return the content of this URL to user, create separated server that doesn't have access to sensitive information like admin panels and so on. That's what I would recommend, basically. All right, now let's move on to injection. Injection was always in top 10 standards since ever, probably. But now injections contain only cross-site scripting, right? So that is now, as I said at the beginning, they wanted to push more content to that standard. So they basically merged cross-site scripting to injection. And probably a lot of you knows what is cross-site scripting injection, but let's take a look. I will try to explain what it is on really simple example. So let's say we have some website like that, and we have parameter username, some user, and we have piece of PHP or whatever that basically render that document, and it's creating some div with username. So probably everything is fine here because we will get HTML like that, just div with some username. So what can go wrong? Let's take a look at this para. What happens if someone, like the bad guys, they will try to inject something like this? You've been attacked. What will happen? Actually, the rendered HTML will contain alert, and that's something that will be annoying, not really danger for user. But if you can imagine, we can explore that path even further, and we can go to solution like this, right? So in username parameter, we will be actually injecting entire form, right? So now, instead of username, we'll have our form, and the user will be prompted to provide his password. And after clicking the button login, the password doesn't go to your server, it will go to that server and it will be stolen. So please always validate your input. In the previous slide, I told you validation is not enough. That's true, but it's good beginning. And to prevent cross-site scripting, you should always sanitize your inputs. That's the first rule. And where are the other examples of injections? So SQL injection is something that everybody probably know, but someone told me use HQL injection and you will be safe. And HQL is from Hibernate. It's Java framework. And indeed, HQL is a little bit more secure because it doesn't allow to use union operator, which is kind of benefit from the perspective of security. But it's not 100% secure, because you can imagine if you are Amazon and you know, for example, next Harry Potter is coming before Christmas, and you only know that you don't want to reveal it to your customers, but you can query like that. Your customers can search through input, but only through published ones. But if there is some smart user that want to check that information, he can provide input like that. And that will cause that this part will be actually omitted, right? And in that case, we'll get all the books. So probably we will reveal information that we don't want to reveal, in that case about Harry Potter. And that can be explored as well. You can't really return the password even if you keep it in your database for some reason. You shouldn't do that, but even if you do that, that won't reveal that information to the user, but it will be in logs. So if the bad guy has somehow access to your logs, he will get the password or any other sensitive information, and it will be HQL injection. So as a homework, there are other injection. I don't really have time here today to cover all of them, but you can see there like OS command injection, LDAP injection, HTML injection, server-side template injection. But to prevent all of them, there are probably many solutions, but what I would recommend to remember about validating your input and sanitizing it. Let's move to another category. Security misconfiguration. So as you see, and I mentioned at the beginning, that part is now considered as misconfiguration. It has its own bullet point. It was A4 and now it's A5, and the category is much wider, much broader. So what is all about XML external entities? What is the problem here? So the problem here is line number 2. And that you, from XML, you can actually access your OS, right? And you can check users. You can check what our users are in your system. And remember, I told you, bad guys, they are not looking only for your password, they're looking for information. So you don't want to reveal what users are in your OS, because they may be the same user that database, so they will get that information, right? And you don't really want to reveal that in XML response in your API. So how to prevent that? So there is a reason why it's misconfiguration, because it's a matter of configuration actually. And to prevent that, you just need to disable it. right? So this is the name of the feature, set it to false, you are safe. Another misconfiguration, billions laughs attack. Maybe some of you heard about that, maybe some of you not. It's really funny attack. And it also assume you have XML configured in the wrong way, basically. So what is all about that? So you have entities in XML. It's quite advanced, right? You can have entity and you can reference those entities. And you can multiply lines like this. You can reference the line 6 from the line 6 from 7 and so on. So you can create simple file, right? Like this. It has only 15 lines, but it actually can be multiple gigabytes. So it will be huge load. If your user is able to send something like this to your server, the server will crash and you will actually have those attacks. Someone, when I gave that presentation last time, someone pointed out it doesn't have to be DDoS, because it can be only one computer broken, right? So if you have one computer that have like 6 gigabyte of memory, and you will send him a file that is 6 gigabyte, that will probably crash at some point, and you will have not really easy moments in your career, I would say. So how to prevent billions laughs attack? Again, it's misconfiguration. So it's simple. You have the name of the feature, but in that case, you have to set it to true, because it is written, these allow doc type, right? Right. That's it about misconfiguration. Let's move to cryptographic failures. So what can go wrong with cryptography? So I will tell you the story here. So this is the logo of company that I'm currently work for them, and my boss told me that this is our new logo. We have to encrypt that logo because this is very sensitive. Nobody can see our new logo, right? So I thought, okay, I know something like AES, right? I heard this is good algorithm. It is advanced encryption standard, right? It's advanced, so it has to be good. So I took the image. It is basically digested here. I opened that and I encrypted the image and I sent it to my boss. And he's calling me as something is wrong. You are revealing some information. You are revealing the shape. So what I did wrong, like still I'm revealing the shape of our logo, right? It is not really encrypted if you are revealing some information. So the problem here is the mode. So I haven't read the documentation, because the documentation of AES is saying what is ECB and what are the available modes. And ECB works like that. It's simple mapping. It is mapping from plain text to ciphertext, one-to-one, right? So if you have to map something, that will be, if you want to encrypt something, that will be encrypted, but you will still reveal that information because it was encrypted one-to-one. So how to solve that problem? You can just change the mode. Instead of EBC, use CBC, right? So in that mode, we have initialization vector, which make things random, basically. So to change the code that I showed you, what you only need, you have to read the documentation, you have to change the mode to CBC, and you have to use the vector, initial vector, which has to be random, right? And in that case, the same picture encrypted looks like that. So nobody knows what was encrypted if doesn't have the key to decrypt it, right? Yeah. So actually the story didn't happen. I made up the stories to make it more interesting for you, but the code actually works. And if you use that exactly that image and you will encrypt that, you will get the results as I show you. So this is real problem. If you want to encrypt something, just read documentation. That would be my general advice. Another thing, this is something not really new. I would say they just changed the name. Previously, it was using components with known vulnerabilities, but now it's more general, vulnerable and outdated components, right? And I don't know if you remember, that was a year ago, I would say there was a problem with log4j. This is the library to basically log something in your app in JVM world. So I remember that was everywhere. That was in CNN, that was in Poland, it was in Onet. Basically every media was telling about that something is wrong with software and you have 0-day vulnerabilities. And yeah, people were crazy because you would able to basically explore your system, and the problem was that this library was used by so many Java applications, and the attack was really simple. We can use curl. If we can some server, we can basically send any header. And if there is a reference to LDAP server, we can send some data to that server in this line, right? Log info, we are just logging. We don't do any rocket science. We just log what we get in the header. And in that case, we can send some information to the attacker server. So for example, I found this tweet. So this is getting very interesting, because actually you could refer to environment variables. And again, in environment variables, you usually have sensitive information. You may have some passwords, some tokens, whatever. If you have log4j below that version, below 2.15, you have problem. And because you can reveal your password to your database. But what is actually the clue of not using outdated components? I would say like the most dangerous things is like everybody is interested to exploring that. So you see that tweet, but there was so many tweets in this topic and so many ideas how to explore this weakness. For example, I saw one interesting. So, guys, there are like Google cars, they are driving around the city, they are scanning Wi-Fi names. So they are storing on the Wi-Fi names. So somebody wanted to test it and try to inject through Wi-Fi name, right? So this is again the reason why we shouldn't use outdated components with unknown vulnerabilities, because so many people will try to exploit it. Not necessarily bad guys, but maybe someone just for fun. But anyway, we don't want anyone to get our passwords to database and get our sensitive informations. What else? So how to prevent that? You have basically like scanners that show you if you use outdated components, outdated dependency. I personally like that one, Sneak. And I like that because of the reporting. So if you start to use some scanning like SonarCube, you can be overwhelmed with amount of reports. So it shows you like your application is totally broken. You have thousands of outdated components. But in that case, take a look at priorities. Usually we'll have a lot of in low, some in medium priority, and in high priority, you should have always 0. I would say if you have a number greater than 0, you should react immediately. Because this is something really important to fix, probably something that is very easy to explore, and you may end up in trouble. Right. So we know how to prevent ourselves from outdated components. Let's take a look at the next point. identification and authentication failures. Before it was broken authentication, but it's not only broken authentication, but any failures can happen. And to give you an example, there is something like non-algorithm attack. So what is this? This is basically JWT. It's kind of standard. We use that for authentication in almost every web application. And it has 3 sections, I would say, divided with dots. 1 dot, second dot. So those are 3 sections. First section is header, and does contain algorithm that we're going to use to validate the file. Second is just second one is just payload, and the third one is signature, right? You have that here. Header, payload, signature. And that's basically JWT. And that's how it looks in plain text. So this is the algorithm. This is type, doesn't really matter. And this is what matters. So this is the role we're going to use. So in that case, we're going to use the role some user. But what if we change the role to admin? Is that going to happen? Like if we just change the content of that file? Not really, because we have algorithms that validate our content based on signature. So we will get some error message, no, you can't go. But what if we change the algorithm from HS256 to non-algorithm? So believe me or not, but it was a common problem because developers basically didn't check the algorithm, and if algorithm didn't match what they expected, they just let attacker pass. So it was really an issue. But of course, now if you use just some library that handle JWT for you, you shouldn't have that problem unless you work in Auth0. Because they also prevented that attack, but they forget that someone can change the letters, and that small letters was an issue long time ago. It's not true anymore. They fixed that, of course, but yeah, that was possible to change the algorithm with none and be able to be locked in Auth0 as anyone. Basically, you were able to modify the JWT. So you can imagine the consequences of that. Right. Another one, problem with logging. I show you at the beginning one problem with logging, but I'm going to explore it a little bit more. So if you have line like this, probably this like card number. Right? So probably someone on code review will tell you, oh man, don't do that. Don't reveal some personal information in logs. That can end up really bad. But sometimes you can log something and be unaware of that. Let's take a look at example like this. So basically, this doesn't look dangerous. At the beginning, we just log errors. We caught some exception on that user, but we use toString method, and that really depends on implementation. Like in Java, very often toString contain all the information from the class. So it might also contain password or some sensitive information of the user, and it's not really visible that it will be logged in your logs, right? So be careful. Whatever you log in your logs, always double check. What can go wrong else? Output neutralization. So sometimes it won't be really the information that you shouldn't log, but someone can use your logger to create trouble for you. So that code is actually very good code, I would say. We are validating the param. We are getting the param from request. So we did our homework. We do some validation. We parse the int. So if someone will push some string instead of number, then we will log that in our log, failed to parse 21. So if I ask my user for age and they put 21 like as a text instead of number, I will get the error. No problem here. But the problem begins if someone started to explore that. So if we don't neutralize, that's the key. If we didn't neutralize our input, someone can, instead of sending 21, it can send 21 plus this random, seems to be not a random thing, but actually it's not really random. It will result in something like this. So first line is what we expected. Second line was injected. User logged out bad guys. So you can imagine a scenario when there was some attack in your company and cybersec team is on it. They want to explore, then they want to know what happened. But someone polluted logs, someone injected the lines that prevent investigation. So that can happen, and we should be aware of that, right? And let's go to the end. Last but not least, broken access control. This is now number one. And broken access control is, access control is always broken. Almost every application, something is wrong. The classic, I would say, example is with API of files, right? So let's take a look at this line. I want to know the files, all the files that this user has access. So I get the numbers. This is ID of the file, 99, 333. And I have another endpoint. I want to get the content of that file. So I want to get the content of file 99, and that's fine, but I can also get probably the content of 100 and 101, 102, and so on. So maybe this is not a good idea to basically allow everyone to read that without verification. We have to always check the access and the privileges of the user. And the second good practice is don't use numbers as identifier, because someone can iterate over that numbers and can explore it. So what about that solution? Let's say we don't use numbers for files ID, but we use UID. Is that a good idea maybe? So we can think it is good, but you have to remember, like, UID is not always random number. UID version 4 is actually random. It shouldn't be used as a random generator, but it is random. But other previous versions, they are not random. They have known weakness, and it seems to be just random number. But actually, if you can go deeper, you can foresee that number if you use UID in the version below 4. So we went through a lot of examples, and I actually want to say thank you for hearing me. If you want to reach out to me, I'm on LinkedIn. I'm very active on Instagram, not really about security and stuff, but more about traveling. I also on Twitter. So whatever works for you, you can reach me out there. If you have any question about presentation, this is the time. And we have 2 minutes, so probably I will handle some of them. If not, then please reach out to me in private. Unfortunately, I don't see if anyone is writing some questions, so let's wait a second. If not, then thank you very much again. I appreciate that you will hear and we learn something about it. Dzięki, Grzegorz. And see you next year, hopefully. Bye-bye.